Hi. So in this video, we'll continue our integral course. And this is the first question. We have integral of tan x plus 2 tan 2x plus 4 tan 4x and 8 cot 8x. So what we'll do here is there is a very important and very useful identity in trigonometry, which is tan x minus cot x is equal to minus 2 cot 2x. So the proof of this is fairly straightforward. You can do sin x by cos x minus cos x by sin x, and you'll realize that it will become sin x cos x and sin square x minus cos square x. The top part is obviously minus cos 2x, and here it is half of sin 2x. So you'll get minus 2 cot 2x, right? So we'll try to use this identity to simplify this expression. So what we can say is if I add a cot x to it, if I add a cot x and then subtract a cot x, so this will become tan x minus cot x, right? And plus 2 tan 2x plus 4 tan 4x plus 8 cot 8x, right? So I've just changed a little bit. I have tried to get this expression in. And in order to do that, I have to add a cot x here. So this becomes minus 2 cot 2x. Now minus 2 cot 2x plus 2 tan 2x. These two together is tan 2x minus cot 2x will be minus 2 cot 4x, and this is 2. So it has become minus 4 cot 4x. And this together with this will become minus 8 cot 8x. And again, repeatedly applying this to this, it cancels out this, right? Minus 8 cot 8x will cancel out the plus 8 cot 8x. And so your integral boils down to simply cot x dx, right? And the answer for that is ln mod sin x. So this is very easy, but only if you are aware of this identity and you use it intelligently here. So you can try to write it as tan x minus cot x and add a cot x to it. And then what happens, it telescopes sort of, and you keep getting higher and higher things, and you eventually get a minus 8 cot 8x, which cancels the plus 8 cot 8x. So fairly simple question, but has a trick. The next one that we look at now is this one. This is the question. You have integral of 2x power 6 plus 15x power 4 plus 2x square plus 3 multiplied by cos 2x dx. This is equal to f of x sine 2x plus g of x cos 2x plus k, where k is a constant and fx and gx are polynomial functions. Fx and gx are polynomials. So the question is first asking you to find integral of gx by f of x dx, right? So basically we have to figure out what is fx and gx. So in order to do that, we'll have to integrate this expression. And the way I would like to do this is split this integral into two parts. Notice that you can take x6 and x square. You can take x square common and it will become x power 4 plus some constant, right? So I'll group this together, 2x power 6 plus 2x square multiplied by cos 2x dx plus integral of 15x power 4 plus 3 multiplied by cos 2x here, right? Now, this integral, it is useful to do it by parts. And I will take this as the first function so that I have to differentiate it and it becomes smaller. And this is the second function. So doing by parts here, I get 2x power 6 plus 2x square. Integral will be sine 2x by 2 for the second function minus differentiation of this. So that will become 12x power 5 plus 4x multiplied by sine 2x by 2 dx. And then I will do integration by parts on this also. Here also, this will be my, actually, if you think about it, if I take this one here as the second function, right? And this one as the first function, I will get an x power 5 and all, right? So let's try that because this is similar to this, right? So I will do integral of 15x power 4 plus 3. So that will be 15 by 5. So x power 5, and this will be 5x power 5. No, not 15 by 5x power 5. 15 by 5x power 5 plus 3x minus integral of this, so 3x power 5 plus 3x into minus of 2 sine 2x. So minus minus becomes a plus, so it becomes a 2 sine 2x. Now, this integral, right, is 6x power 5 plus 6x, and here you have a 2x power 5. Actually, here also you have a 6x power 5. 6x power 5 plus 2x here, sine 2x. And here you have a 6x power 5 plus 6x sine 2x. So you can just subtract these two integrals and you will be left over with 4x sine 2x integral plus. So this has been cancelled and this has been cancelled. And this is anyway an answer. And now you just have to simplify this, right? 4x sine 2x, that is a very easy integral by parts, right? So we can do it like integral of 4 times x sine 2x will simply be, take this as the first function and this as the second function. So x into minus cos 2x by 2 minus integral of minus cos 2x by 2. So that is a fairly straightforward integral. You can do it yourself. So, and then you just write the answer. You add up everything and you get the answer. So the trick here was choosing the right set of algebraic expressions to be paired up together. And basically, if you don't get it on the first time, try again. Like if I chose this and this together in the beginning, and this as the first and this as the second function, I will differentiate this, which will give me x power 5 plus x. And if I choose this as a second function, then I will integrate this, which will also give me x power 5 plus x. So that is good because then that we can combine the integrals like this, and it got cancelled and became a much simpler integral, right? So that is what I was aiming for. And beyond this point, you can easily evaluate the function. So once you do the integration, you will realize that the answer comes out as, I will just write the answer for your reference. Your f of x will come out as x power 6 plus x squared plus 1. And your g of x will come out as 3x power 5 plus x. Now the question was not this. The question was basically integral of f of x, g of x by f of x, right? So if you do integral of g of x by f of x, you realize that this is 3x power 5 plus x by x power 6 plus x squared plus 1. So notice that now you can take this as t and the top part will be just 6x power 5 plus 2x dx is equal to dt. So you can take 2 common and 2 into 3x power 5 plus x dx. So 3x power 5 plus x dx becomes dt by 2, right? So this integral can be evaluated like this, dt by 2t, so half ln t, right? So basically the question becomes easy once you have figured out how to do the original integral from where you get the polynomial functions gx and f of x, right? Okay, so let's move on to the next one, which is this question. Question number 22. This talks about let integral of x square minus 1 e power x square plus 4x plus 1 dx be equal to e power x f of x plus c, right? And now the question is asking find f of x first of all, and then he's saying if alpha is one irrational root, is one irrational root of f of x plus f dash x is equal to 0, dash x is equal to 0, then alpha power 4 plus 4 alpha cube plus 2 alpha square plus 4 alpha is equal to what? Right, this is the question. So in order to solve this, the best way to do it or the fastest way to do it would be to find differentiation here, because then you'll immediately get f dash x, right? So if I differentiate both sides, I will get x square minus 1 e power x, x square plus 4x plus 1 is equal to e power x f of x plus e power x f dash x, right? So I can immediately say e power x f of x plus f dash x bracket, and here you have e power x, x square minus 1 into x square plus 4x plus 1, right? So e power x can get cancelled, and you have f of x plus f dash x is equal to x square minus 1 multiplied by x square plus 4x plus 1, right? Correct. So therefore, alpha is an irrational root of this equation. So this has roots x is equal to plus minus 1. So alpha must be a root of this. Alpha is a root here. So therefore, you should have alpha square plus 4 alpha plus 1 is equal to 0. And now what we can do here is in this expression, we can take alpha square common, and you have alpha square plus 4 alpha plus 2 plus 4 alpha, right? So this will become alpha square plus 4 alpha plus 1 is 0. So this is 1 plus 1. So it is alpha square plus 4 alpha. This whole expression will become alpha square plus 4 alpha, because this part is actually 0 plus 1, because you can say that since alpha square plus 4 alpha plus 1 is 0, plus 2 will be 1, right? So you have alpha square plus 4 alpha, which is equal to minus 1, right? So the answer for this part is minus 1, right? Now, how do you integrate the expression normally? Like if I had to integrate the original expression, if somebody asked me f of x here, right? So let's try doing that. So you have e power x, x square minus 1 multiplied by x square plus 4x plus 1 dx. Now, if you write it as e power x, x power 4 plus 4x cube plus x square minus x square minus 4x minus 1, right? This becomes e power x, x power 4 plus 4x cube minus 4x minus 1, right? Dx. So if I have to integrate this function, right, I need to figure out what should be my f of x and what should be my f dash x, right? So in general, I want to solve this like this. I want to bring it in this form. And I know the answer of this is e power x f of x, right? So what can be my fx, what can be my f dash x is what my question is. So if I take x power 4 minus 4x as my f of x, my f dash x will be 4x cube minus 4, right? So I'll get an f 4x cube in the f dash x, but I need a minus 1 rather than a minus 4. So I should do plus 3 here, right? Correct. So if this is my f of x and this is clearly my f dash x then. So, and the addition of these two functions adds up to x power 4 plus 4x cube minus 4x minus 1. So therefore, you're getting the pattern e power x, x power 4 minus 4x plus 3 plus 4x cube minus 4, right? And that integral answer will be e power x into x power 4 minus 4x plus 3. Therefore, my f of x is coming out to be x power 4 minus 4x plus 3, right? This is my f of x. Once I found f of x, I have basically solved the question, right? Let's move on. Let's look at question number 23. And in this question, what we have to do is we are given let 2i1 plus i2 is equal to integral of e power x by e power 2x plus e power minus 2x dx. And we are also given i1 plus 2i2 is equal to integral of e power minus x by e power 2x plus e power minus 2x dx, right? And I am supposed to find I1 and I2, right? I1 and I2. So in order to do that, I1 and I2 I have to find. You can actually try to solve this, right? If you add both the integrals, if you add both the equations, right, you will get 3i1 plus 3i2 is equal to integral of e power x plus e power minus x by e power 2x plus e power minus 2x, right? Correct. So here, this part can be written as the denominator is basically e power minus x, e power x minus e power minus x whole square plus 2, right? Because then that will become e power 2x plus e power minus 2x minus 2 plus 2, right? And then if I write it like that, the top becomes my differentiation of the bottom, right? Differentiation of this is equal to the top part, which is what I want. So I have something like this here and something like this here. So this becomes basically dt by t square plus 2, and that integral is just simply 1 by root 2 tan inverse t by root 2, where your t is e power x minus e power minus x, right? And this is equal to 3 times I1 plus I2. So that gives you the value of I1 plus I2, right? Once you have I1 plus I2, you can just subtract from here, right? Correct. Or you can actually, like, instead of doing any simplifications here, let's just subtract this equation and this equation, and you would get I1 minus I2. And I1 minus I2 can also be easily integrated because you'll get e power x minus e power minus x by e power 2x plus e power minus 2x. And this time you'll take e power x plus e power minus x whole square minus 2. And it will become dt by t square minus 2, which is also a standard integral. It is 1 by 2a ln x minus a by x plus a, right? So the idea for this question basically is adding and subtracting the original data, and you end up getting integrals which are easier to solve than the original integral, right? So you should try and finish that question off now. Okay. The next question that we look at is this one, question number 24. And here we have let IRx be equal to integral of x power r dx by x power 4 plus 4, 4 plus 4, and x is greater than 0 here. It is given that x is greater than 0. And the question is asking us uh, if I1 root 2 is equal to 9 pi by 16, then limit of x tends to 0, cos of I1x by x square is equal to what? So we have to try to understand what is IRX. So if you think about it, IRX can be written as x power r dx by x power 4 plus 4. It is a standard factorization of x power 4 plus 4, and that is equal to x square plus 2x plus 2 and x square plus minus 2x plus 2. How do I do this factorization? I just complete the square, x power 4 plus 4 plus 4x square minus 4x square. And that becomes x square plus 2x, x square plus 2 whole square, x square plus 2 whole square minus 2x whole square. And now you do a square plus a plus b into a minus b. So if I have this expression here, I know that I can write the top part. If I have to have, say, I1 of x, right? I1 of x, then the top part will be basically x powered 1. So x dx by this thing, correct? X squared minus 2x plus 2, right? So how do I get an x here? I can write the top has 1 by 4 into 4x, and I can say this minus this is equal to 4x, right? So I'll get 1 by x square minus 2x plus 2 minus 1 by x square plus 2x plus 2 and 1 by 4 of that. This integral is my I1x, right? This is an easily doable integral. You can split it into two integrals, 1 by x minus 1 whole square plus 1 minus 1 by x plus 1 whole square plus 1, right? And 1/4 of that, 1/4 of this. So this will become tan inverse x minus 1 by 1 minus tan inverse x plus 1 and 1/4 of that, right? That is your I1x, right? So, okay, once we have that I1x, I want to find the limit of this with respect to x square. So cos of 1 by 4 of tan inverse x minus 1 minus tan inverse x plus 1 divided by x square, limit x tends to 0, right? Now this part here, if x tends to 0, tan inverse minus 1 is minus pi by 4 and minus plus 1 would be pi by, so minus pi by 2. So this part becomes 0, correct? And the other part will also become 0. So you can possibly do L'Hospitals here, right? Uh, let me think. I1 of root 2. We had to find I1 of root 2, right? And that data was given to us, I1 of root 2. So I've just so far not done the integral exactly. Like we know the method by which the integral is done. So as soon as you put 1 here, this integral is doable. 1 by 4 into 4x, and this also works out. And yeah, 4 I1x is equal to this, right? So x plus 1 whole square plus 1. And yeah, I mean, we just have to work through these steps here, like actually evaluate it. That will give you a better expression. So if I evaluate this and use tan inverse formulas, I can possibly get a better expression for this. I will leave the working out of the trigonometry part to you, and the limits and the differentiation here is easily doable. Like we have done limits which are harder than this in other courses. Once you get the actual expression, it will possibly be easy to solve. What I wanted to show you was how to solve this integral. The way to solve this integral is to take cases here. If it was x power 1, I split it like this. If it was x square, I can possibly split it in a different way, right? So that is that. Then let's look at another one. Uh, which is question number 25. Okay. Question number 25 is, if f of x, if capital F of x is equal to integral of 1 plus x multiplied by 1 minus x plus x square multiplied by 1 plus x square plus x square whole bracket divided by 1 plus 2x plus 3x square plus 4x cube plus 3x power 4 plus 2x power 5 plus x power 6 dx. Then find the value of f of 99 minus f of 3. Okay, and we have to find the GIF of this. GIF of this. Okay, so this part actually is 1 plus, if you simplify that part using a square minus b square formula, you have 1 plus x square whole square minus x square plus x square. So this cancels and this becomes just this. So divided by this expression. So this expression I can simplify like this: 1 plus 2x plus x square plus 2x square. 2x square plus 4x cube. Okay, I just want to simplify this denominator here. So it is plus 2x square plus 4x cube plus 3x power 4 plus 2x power 5 plus x power 6. On top, I have 1 plus x multiplied by 1 plus x square whole square. And in the denominator, here I have 1 plus x whole square. Can I do similar things here? Let's take x squared common. We have 2 plus 4x plus 3x square plus 2x power 3 plus x power 4. So what we can do here is, so we can write it as 1 plus 2x square plus x power 4 plus x square plus 4x plus 2x cube. This is the same thing I have written, plus 1 is also there, right? So 2 is 1, so 1 is here, and 2x square and x square, and 2x cube is here, and 4x is also here, correct, and x power 4. So this is x square plus 1 whole square plus this part is 1 plus x square plus 2x. 1 plus x square plus 2x plus 2x plus 2x cube. So this is what I'm getting here in the denominator is 1 plus x whole square plus x square into 1 plus x square whole square plus 1 plus x whole square plus 2x 1 plus x square, right? So correct. So we have 1 plus x whole square plus x square 1 plus x square whole square plus x square 1 plus x whole square plus 2x 1 plus x square. So I will take 1 plus x square common here. I'll get 1 plus x whole square and 1 plus x square. Plus I'll take 1 plus x square common here as well. And I'll get x square into 1 plus x square plus 2x, right? So this will become x power 4 plus x square plus 2x. Okay, I'll just keep it as it is. If I keep it as it is, however, the integral is not getting solved. So we have to think about what we can do in the denominator. Okay, I'll just do it on the next screen so that we have more space. So the integral, the top part was easy. Top part was 1 plus x square whole square. Denominator was x power 6 plus 2x power 5 plus 3x power 4 plus 4x power 3 plus 3x square plus 2x plus 1, right? I have to simplify this somehow, right? So, okay, maybe it has similar factors which get cancelled. So let's see. In order to factorize this, let's do it by factor theorem. Let's check whether -1 is a factor. So -1, if you put 1 minus 2 plus 3, 4 minus 2, so plus 2 minus 4 minus 2 plus 3 is plus 1 minus 2 minus 1 plus 1. Yeah, x minus 1 is a factor. So what I'll do is x power 5, x plus 1 plus x power 4, x plus 1 plus x power 4 plus 2x cube, x plus 1 plus 2x cube plus 2x square, x plus 1 plus 2x square. So plus x plus 1 plus x, so plus x plus 1, right? So x plus 1 is a factor. So I'm just taking x plus 1 out and you're getting x power 5 plus x power 4 plus 2x cube plus 2x square plus x plus 1. Now check this polynomial also. This polynomial also -1. Let's check. -1 plus 1 minus 2 plus 2 minus 1 plus 1. Yeah, -1 is again a factor. So again x plus 1 will come out. And let's try to write what will come here. So x power 4 x plus 1 plus 2x square x plus 1 plus x plus 1. So what I will get inside is x power 4 plus 2x square plus 1, right? Which is now straightforward. This is just simply x square plus 1 whole square. So the denominator is actually this. Now notice that simplifies your matters immediately. You have 1 plus x square whole square divided by 1 plus x whole square, 1 plus x square whole square. You cancel off, you get integral of 1 by 1 plus x, which is ln 1 plus x. And now that is your f of x. F of x is ln 1 plus x. So f99 minus f of 3 will be ln 100 minus ln 4, which is ln 25, right? So that will be your answer, ln 25. And if I have to do ln 25, I know it is going to be something 2.71828. So it will be greater than 3. So GIF of ln 25 will be equal to 3. So notice that the question was tricky because there was a big expression in the denominator that we had to simplify. However, if you don't lose patience and try it properly and try to get factors by remainder and factor theorem, here I just started out by seeing whether x plus 1 is a factor or not. I put x is equal to -1, factorized it. Again, the remaining 5th degree polynomial, again, I checked whether x minus 1, x plus 1 is a factor or not. Again, I took it out. And once I got the 4th degree polynomial, it was obvious that it is x squared plus 1 whole square, right? So a little bit of patience and perseverance is required to be able to solve certain questions like this. That's all for now. I will continue with more problems in integrals as we go ahead in the course. See you next time.